Welcome to all. So today I am going to present an article on the topic Discrete Wavelet Image Compression. As you all know, image compression plays a very vital role for the reduction in data size. Whereas if we use wavelet, the quality of the image will get enhanced. At the same time, the high frequency components will get reduced. That means the noise in terms of high frequency components will get reduced. So what is wavelet? Wavelet is a wave, small wave, which rises from zero level to a particular height, amplitude, and then again coming back to the zero level. This is called a wavelet. So this wavelet is used to improve the quality of the image, which is normally used for compression application. Normally compression applications can be used for lossy and lossless image compression. Where lossless image compression is widely used for medical applications, so this wavelet technique is quite useful for medical applications. So normally there are two types of image compression: Fourier transform based image compression and wavelet based image compression. What do we do in Fourier transform is, you can convert time domain to frequency domain, but you cannot convert a frequency domain to time domain. So that is also possible in wavelet transform. That is why it is quite useful. So for example, if we take a data compression, or any other image compression technique, so we take the image that is 255 into 255 image size in terms of blocks, both in discrete cosine transform, that is basis of Fourier transform. It is considered by means of a block. So it is like two blocks, okay, 255 into 255 blocks. So if we take the first two blocks and compress it, the edges won't get compressed. So you just imagine how many edges will be there for 255 into 255 blocks. So it is very, very difficult. The quality of the image will already get reduced and the data size will also increase. So that is the only solution for this best application is wavelet image compression. Instead of block, in wavelet we use pixels. So how to do this in wavelet compression is, we take an image, we represent that image in terms of pixels. So they are decimated into two blocks. One is approximate and detailed coefficient, that is low frequency component and high frequency component, like this. It is an image, it is divided into two components, low frequency components and high frequency component. So the idea is to remove the high frequency component totally. That is the idea of wavelet. So first again what we have to do is, again split this into four levels. So where you will get, here it is low, 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 high, high, low and high, high. So wherever the high components is there, that can be rejected. So only take the low, low frequency components. That means there is no noise. So this will reduce the memory size further and the quality of the image will get improves. So even then, again you can split this into two halves, that is low, 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 high, high. And again split this into four halves, so that is low, 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 high, 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 low, low, high, high, high. So again wherever there is a high component, you can again split that, so you will get low, low, low. So similarly further you can improve until you get only the low frequency component. This process is done. So this is the best way of doing an image compression using wavelet. That is why in Coimbatore most of the medical transcriptions are widely used using this wavelet compression, and it is very fast to do medical compression, medical transcriptions. So the medical transcription application has improved a lot because of this wavelet compression. And this is quite used for science, mathematics, signal processing applications, micro electromechanical systems and all other types of VLSI design products. And hope this idea will give you and will trigger you for the applications like next level of applications like fractal image compressions, adaptive image compressions and so on. Thank you.